Now we'll see in detail the working of the intrinsic semiconductor, which is one of the type of the semiconductor. Okay, इसको हम क्या बोलते हैं? प्योर सेमीकंडक्टर भी बोलते हैं इंट्रिंसिक सेमीकंडक्टर को। एक हमने देखा था व्हाइल सेमीकंडक्टर कि जो भी कंडक्टिविटी प्रॉपर्टी है सेमीकंडक्टर की वो डिपेंडेंट है टेम्परेचर पे, डोपिंग पे और अप्लाइड वोल्टेज पे। ठीक है, तो जो इंट्रिंसिक सेमीकंडक्टर है उसकी जो कंडक्टिविटी है, कंडक्टिविटी डिपेंडेंट है ऑन द टेम्परेचर। ओके, so how it works, we'll see. First we'll go to the image for the better understanding. Okay, so suppose here it is a intrinsic semiconductor we have considered. Okay, here it is a intrinsic semiconductor. We are applying heat or a light. Okay, so light is incident on the intrinsic semiconductor or a heat we are applying to the intrinsic semiconductor. तो क्या होता है कि पहले जो इलेक्ट्रॉन्स रहते हैं और द ऑल द एटम्स ऑफ द सेमीकंडक्टर जो वो रहते हैं इन द वैलेंस बैंड, दे आर इन द वैलेंस बैंड. ओके, taking the another pane. Yeah, so here it is a वैलेंस बैंड. ओके, सो वैलेंस बैंड में सारे इलेक्ट्रॉन्स रहते हैं फॉर द इंट्रिंसिक सेमीकंडक्टर. ओके, इलेक्ट्रॉन्स और वी कैन से ऑल द एटम्स आर प्रेजेंट इन द वैलेंस बैंड. बट जब हम हीट अप्लाई करेंगे ऑन द इंट्रिंसिक सेमीकंडक्टर और लाइट अप्लाई करेंगे तो क्या होगा? ड्यू टू हीट एनर्जी जो इलेक्ट्रॉन्स वैलेंस बैंड में है वो इलेक्ट्रॉन्स ड्यू टू हीट इट विल मूव टू द कंडक्शन बैंड. ओके, वो कहाँ पे जाएंगे? इन द कंडक्शन बैंड. सो ओके, कंडक्शन बैंड में इलेक्ट्रॉन जाएंगे फ्रॉम द वैलेंस बैंड. जब ये इलेक्ट्रॉन्स फ्रॉम वैलेंस बैंड टू कंडक्शन बैंड जाएंगे उस केस में यहाँ पे जो इलेक्ट्रॉन्स का वो क्या होगा? यहाँ की स्पेस वैकेंट करेगा. ओके, मतलब यहाँ पे कुछ नहीं रहेगा. वैकेंट हो गई स्पेस मतलब क्या है कि जो वैकेंट स्पेस है यहाँ पे रिप्लेस होगी विद द होल. ओके, वी आर कॉलिंग इट इज अ होल. अगेन अदर इलेक्ट्रॉन सपोज हमने कंसीडर किया ये इलेक्ट्रॉन भी फ्रॉम वैलेंस बैंड टू कंडक्शन बैंड गया तो यहाँ यहाँ का भी जो स्पेस है वो वैकेंट हो जाएगा और वैकेंट स्पेस रिप्लेस होगा विद द होल. होल इज हैविंग द पॉजिटिव चार्ज. Okay, so like this we are getting the combination of electron and hole pair. Okay, so electron are in the conduction band and holes are in the valence band. So simply we are calling it is a electron hole pair. Okay, and it happens due to the heat or a light energy simply. Okay, so this is the main functionality in the intrinsic semiconductor, how it happens. So now we'll see one by one at different temperature how it works. So firstly, suppose we are considering it for the at temperature 0. Okay, so at 0 Kelvin means there is no any heat being applied to the semiconductor material. Okay, so in pure semiconductor at 0 Kelvin all valence electrons are bounded to their atom in the covalent bonds. Okay, or simply in the valence band we can say. So there is a atom's covalent bond in the valence band. So all the electrons will be in the valence band. Okay. So no free electrons are available for the conduction purpose at 0 Kelvin. Okay. Hence at 0 Kelvin it behaves like an insulator. Okay. We have seen here when we are applying the heat, so the electrons are moving from valence band to the conduction band. But if you are not applying any heat, so at 0 Kelvin we can say, so it acts as a insulator. Okay, it will act as a insulator. So there is no free electrons are available for the conduction purpose here. Okay, so no free electrons are available for the conduction purpose we can say. And when we're applying the heat at room temperature or at 300 Kelvin approximately, so what happens when the temperature increases? Okay, some valence electron gain thermal energy. Okay, so the electrons which are in the valence band, these are the electrons which are in the valence band gains the which gain thermal energy, okay, which gains thermal energy. So these electrons jumps from valence band to the conduction band and leaving behind the empty spaces. मीन्स जब ये वैलेंस बैंड टू कंडक्शन बैंड जाएगा इलेक्ट्रॉन, तो यहाँ पे एक वैकेंट स्पेस जनरेट होगी, और जो वैकेंट स्पेस है वो रिप्लेस कौन करेगा? होल. वी आर कॉलिंग इट इज a hole. Okay, so now two charge carriers are being formed simultaneously. One is free electron and one is hole. So in the conduction band, we are having the electrons, and in the valence band, we are having the holes. So in the intrinsic semiconductor, semiconductor current flows due to the electrons and the holes too. Okay. So the electrons are in the conduction band, move freely when we are applying the external electric field. Okay, and holes acts like a positive charge. Okay, holes acts like a positive charge when the neighboring electron flows from negative terminal to the positive terminal. At the same time, hole will move from the positive terminal to the negative terminal, which is opposite of the electrons. Okay, so this is the working of the intrinsic semiconductor. Okay, so we'll see some bonding, how the bonds is there in the intrinsic semiconductor. Here, if you see, we have considered all the silicon atoms. Okay, so these are the silicon atoms. So all silicon atoms will have the 4 valence electron in their valence band. So it will combine with the 4 valence electron of the neighboring silicon atom. Okay, so when we are applying the heat, okay, heat is being applied to the semiconductor. So the electrons which are in the valence band, okay, it will move to the conduction band, and here the space will get vacant and it is being replaced with the hole. Okay, this is the same functionality which we have seen inside the band, conduction band and the valence band. Okay, same here. This electron will move to the conduction band and the vacant space will be replaced with the hole. Okay, so here it is a free electron and the vacant space is nothing but a hole. Likewise, the conduction happened with the electrons and the holes in the intrinsic semiconductor.